I'm joined today by our CTO, Mathieu Rene, goes by Matt, and he's our Chief Technology Officer here at HumanFirst. He's got 20 years of experience, 5 patents in technology. He's served as the lead architect for TrueKey product at Intel. He's a proudly self-taught engineer at heart, has extensive knowledge in machine learning, and he's pretty much behind just about everything we do here at HumanFirst. So I'm really excited to have Matt joining me in today's webinar. Today, we're going to have a conversation. So it's going to be more of a fireside chat with Matt. I love that it rhymes. And we're really going to be talking about how to future-proof our generative AI strategies. Matt's got a lot of time working with these products and a lot of really interesting perspective as somebody who's helped build our tool, but is like leading technology and thinking about how these things impact, our own workforce and our own business as well. So I thought it'd be a great opportunity to share some of our insights with all of you. So Matt, thanks for joining us.
Hey, thanks for having me.
Awesome. So maybe a good place to start is maybe let's just start with your perspective on the model landscape. Like, what do you think is kind of going on today, and where do you think things are going when it comes to generative AI and the large language models that are available to all of us?
That's an interesting question because the commercial landscape is growing like day after day, and there's like heavy competition. I think OpenAI still has the edge on a lot of use cases. You see like a GPT-4o and all the improvements that they do to ChatGPT that they bring to their API platform is really relevant. Vertex with Gemini 1.5 now, Anthropic and Cohere, some of the main other players that we see. I think what's interesting with the latest models is that they're starting to bring other modalities. So they're not only for generating text, but they can start understanding images and some kind of videos. So their potential usages expand based on that. And then you've got all the open source side of things where you have Meta has Llama 3, Google has Gamma 2, and then there's Mistral AI that's on the side, and I'm leaving like 100 other different more specialized and smaller models. So it's a super interesting landscape right now.
Do you think that that there's going to be this kind of like consolidation towards like a master model? Like I've heard people talk about that, or maybe other phrases used. Or do you think it's going to go in the total opposite direction where you have even more models out there?
I think it's the latter, but also it's helpful to keep in mind that what we perceive as one model can be multiple models together under the hood, glued together by some logic. There's a machine learning technique called a mixture of experts that is not new, but that is being used by all these model providers where they can build a super large model that's composed of multiple smaller models that are connected together on the neural side. So like they behave as one model, but there are multiple models. And then you can also have like an interface like ChatGPT that may or may not have internal prompting that say, hey, which model should I use for this? And from your perspective, you only see like one interface, but in the back, there's maybe dozens or hundreds of models, like who knows? Ultimately, the big models tend to be more expensive to run, have higher latency, and be more powerful. And the smaller models are quicker to run and therefore cheaper because they require less compute. And we see a spectrum of capabilities. And depending on the task and the usage and the volume, sometimes it's easy to use a mix of different sizes depending on your use cases.
Interesting. So you touched on a few things there I want to get to, like cost and performance. But so in this world where you've got lots of different models, what does that kind of mean for the everyday user? Like, and I'll give you some context in my question. For me, right? Like I'm non-technical. I kind of think of like ChatGPT. I go in, I like write a prompt, right? And I get to
Yeah.
play with the way I do with like Google search or something like this.
Yeah.
Um, if there's going to be, hundreds, thousands of models or whatever, they're all stitched together as you described, like, do I have to become competent with all of these models as a business user, or like what's the play for me in my everyday work?
Yeah. I think you have to become competent at prompting as a strategy to accomplish tasks. It's a different mindset than trying to do things manually, where you have to basically behave as if you had an intern that you're talking to and that you're teaching about the task you want to accomplish, and then get the model to do what you want. Look, right now, I think what's interesting about generative AI in the language space specifically is that the skill sets that you need to become good at prompting are completely disconnected from the traditional skill set of machine learning um,
Hmm.
engineering, where you would have to learn like a lot of math, a lot of like technical knowledge in order to be able to do some optimization. And now all you have to do is like rephrase a prompt and like work at it until you get to something better, right?
So you so to play that back to you, what the average person needs to be concerned about more is really their ability to write effective prompts versus some technical knowledge. Like I think you mentioned like having all these models stitched together. Does that kind of imply then that companies should be thinking about like one interface for people to work out of, or like how do you? I'm just trying to like, what are the mechanics that you think kind of come out of that?
Yeah. Well, I think having one interface that plugs into different models is definitely something useful because like, it allows you to take advantage of the competition and the different capabilities of each model. Gemini, for example, handles video very well. Um, OpenAI has a bit more features. They have like API support for running code like Python and doing retrieval augmented generation. So, like being able to leverage the different capabilities, a different model, ultimately like gives you more benefit in the long term because means that you can do more things.
So, okay, so if we're gonna do kind of more things, how do I start thinking about picking the right model for the right job? Earlier you
Yeah.
talked a bit about performance and it kind of bleeds into that. Like, how should we think about that?
So starting from your use case, and I think maybe we can take a minute to talk about like what do you do with these models first, and then we can go into like picking the right one.
For
I
sure.
think intuitively speaking, like when I speak to my friends and ask them, okay, like what do you use generative AI for? And they'll answer me like I'll write my emails faster, I'll maybe paste in a complicated article or a research paper, and I'll ask the system to give me something more manageable or more understandable so that you don't have to sift through a lot of data. Um, at HumanFirst, we do a lot of things with data at scale. So, like being able to not only ask a question about an article that you've read, but maybe ask a question around like 10,000 articles that you have in your data set. And this can be articles, it could be like conversations between humans. It can be any kind of data that can be represented textually in the end. And when you start going in bigger scale, then the economics of the model start making being more important. So if you're going to run a prompt and say, "Hey, give me the call driver for this conversation," give them a transcript of like 20 pages because the conversation was like a half an hour phone call to your call center, then these are a lot of tokens. So you don't necessarily want to use the biggest model because it means that you have to wait longer to get responses to your questions. And it means that the costs are also higher. So when you pick a model, I'd say try to experiment with the different ones. Start by, let's say, the biggest, latest flagship model, like maybe GPT-4o or Gemini 1.5, and see what you can get, and then go down in size until you maintain the same level of accuracy than the big models, because that means that you're just going to be able to iterate faster.
Mm.
And if you're a company that wants to scale this and wants to run this like every day, that's where like more advanced techniques like fine tuning like can help you create a smaller model that works as good as the big one, but really specialized for one task.
Makes sense. What you're describing, maybe this is just my own naivety, but it sounds like that's maybe a lot of work, right? And not that people should shy away from a lot of work, but I'm gonna pull in a bunch of data. I'm going to test a big model. I'm going to iterate on this. Like we're talking about building maybe like custom pipelines. Like maybe not every organization has the time or the resources or the personnel to do this. So like, are there, I know as somebody like leading technology yourself, like how would you tackle that problem if you were a company that maybe was strapped for resources a little bit?
I think tooling has a big role to play in that space. Like it's always, as a CTO, it's always build versus buy. Like ultimately you have some resources where you can build like pretty much whatever you want given the right time and money. Or you can get something on the market that's already existing and provides integration points so that you can get started today instead of like getting started in like 3 to 6 months or whatever the time it takes to get this going. Like, of course, like companies have different structures. And if you have like a data science team already that owns like the storage and the life cycle of the data that you manage, then like it's even easier to like have them integrate with a solution that allows a business expert to do this experimentation. Because I don't believe that you can entirely delegate a lot of that to just an expert in ML or even in GenAI, but because the prompts that you have to write and the iterations that you have to do really depend on business knowledge and insights on how the business itself operates.
Can you expand on that a little bit? Like what's the downside if it's a technical person doing this work, and what's the kind of the upside if it's a business person doing the work?
I mean, there's no it's a downside of the person has technical skill set. It's more that the person needs to know how the business works. So let me give you an example. Let's say you're trying to understand signals inside a large volume of conversations. Like if you don't know about the business and its procedures, like you're going to get some data out of this data set, but you're not going to ask the right questions as to better understand why these things are happening. And ultimately, like software solutions are shortening the feedback loop. Like you could like tell your data science team to go and crunch and write graphs of process data and like feed that back into BI systems and then have meetings with them like a week later to analyze the results. But the feedback loop being like 1 hour or 10 minutes makes a huge difference in your ability to make the right decisions and do a lot more of these projects, because your data science resources are always going to be constrained because everybody wants to get insights from data at some point.
So that's kind of on the prompting side, but like what about on the data side? Like surely if you've got the business user who's asking questions of the data, like it makes me think of that expression like garbage in, garbage out. Like surely, there's got to be some way to make sure that the data that's being queried is, the right data set, that it's in the right shape, et cetera. Like how would you start thinking about that?
That's especially relevant when you start building the assistants that will be used internally. If you give your assistant access to like everything at once, that it doesn't know that like some data is outdated and some data is more recent or more relevant. So that's when it becomes important to have some sort of curation step. And again, tooling can help there, where you can go and you can see by some sample questions, like which documents like are more similar or would answer the question directly, a bit like an advanced search interface, because that's what these assistants end up using under the hood, using a technique called retrieval augmented generation, which is a mix of traditional search and semantic search usually. So you want to see what data is being exposed to this search, so that you can make sure that it's up to date. Because just like, I mean, it's a bit of software anecdote, but just like documentation that's stale doesn't help you, because like you need to access data that's relevant, that's recent, in order to answer your question. And the same applies to GenAI systems.
There, it's making me think a little bit around kind of this topic of compliance and, data privacy and security, et cetera. Like, surely, you're going to have a team that must have some oversight over all of those components that's going to be kind of helping structure this. Like, can you talk a little bit about that?
Yeah. And I guess this is one advantage of being able to pick the model that you want to use separately from the interface and the tooling that you use to build your application. Because if your organization is a Google shop, then maybe you haven't yet vetted or done all the compliance checks for OpenAI. Maybe you don't have agreements with them, and you're forced to use, let's say, any of the Google model, maybe Gemini in this case. And the opposite is true if you're like a Microsoft shop. Maybe you have access to Azure, and you need to use some OpenAI models that are available by Azure's OpenAI service. So being able to select the model has a big impact on that. And another important thing for compliance is usually data residency. If you're a European company, you may not want your data to leave the European Economic Area. So having a provider that can let you control where these models are deployed can help you meet these compliance goals. And you can also run your own models. Like there's a lot of implementations that are open source, and even Google's makes it easy to deploy open source model on your own infrastructure, because it's like a one-click deploy. You pay for the compute, and we provide you with the API. So that's another way that you can meet your requirements, because you can keep that inside your own virtual private cloud, which like has all of your security perimeter configuration and compliance requirements.
Got it. So we're in this world where there's lots of different models. You've maybe stitched some of them together. You've picked the models that work for the right jobs. You've got business people kind of interacting with the models, creating prompts that give them the outputs that they're looking for their various business purposes. We've got data scientists who are helping kind of curate that data or get the right data available for the business people to explore. How would you go about structuring your team or organization? Like, I think of that expression of, you got to put the right people in the right seats on the bus, right? So how do you start thinking about that?
I think ultimately everybody can get value out of GenAI. But I would try to like pick a way to democratize access to these models and make sure they don't hit any hurdles into being able to use them, because ultimately you're talking about performance gains. So you can always pick the highest value team to start experimenting with it. But I'm sure like in a lot of companies, like a lot of people are just burning to like start getting access to these technologies, because they know it makes their lives easier. And that means that they can do more in one day, ultimately.
What about like people who might feel a little bit of fear around I don't know, the future of their role? Like, I don't know, maybe it's slightly off topic when it comes to like future proofing the AI strategy for the business, but I think like, these big picture company topics, always kind of wind up coming down to the lowest unit, which is the individual.
Mhm.
What are your thoughts on that? I know maybe a bit of a sidetrack.
I think roles are always evolving, and you just end up like doing the same task differently. I think there is going to be some scaling factors that mean that maybe less resources are needed for some roles, but like if you look at the history of like industrialization and how like automation impacted the market, like you saw a lot of new roles being created as well. And like we're in an economic structure where like perpetual growth is like very incentivized. So if at every level of the company you start having these accelerators, then that means that you can grow faster ultimately. So it's true that if you just look at one business unit, like maybe they can do more, that maybe they don't need like 100 employees, maybe they can do it the same thing with 80. But if you start applying that at every level, it means that everything is accelerating. So in the end, you're just gaining more performance out of everybody.
So people should embrace it, get on board, start trying things,
Yeah.
learning, etc. Okay.
And
Uh,
even, I mean, even as software engineers, like the tooling that come out where you can interact with your code using large language models, get completions, like there's a bit of fear in the community of like, oh, are like AI systems going to be able to write like code on our behalf? And then you look at your backlog of things that you wish you could do, but that you can't do, and you're like, well, we have like more and more work coming because these systems are never complete, and you're always making tough prioritization decisions based on what you can do with your resources. So I suspect that's the case for a lot of businesses too.
hmm. What role do you think an organization plays when it comes to equipping their team with the right skills to use, this technology that we're talking about today?
I think there's definitely a training component to it. Like we talked about a few use cases, like and like from the different types of easy use cases like content generation and summarization to more advanced use cases like understanding data sets and so on. Like there's flows that are possible where you just need to know that you can wire them up together in order to do that. And it's sometimes not obvious unless you have training or previous experience doing so. Even in the content generation space, let's say you're having to write procedures to follow some legislation, you can break that down into different steps and say, hey, have a prompt that goes and read the legal text and generate something more understandable because we don't need all the exceptions and all the legalese that goes with it. And then you can have another prompt or agent that goes and consumes that and then creates procedure around it. And then you can have some validation that cross-references back to the legal text. So you can build these flows in order to build procedures in your business as well. And you got to start exploring. You have to treat that as something new that you're curious about. And like
Yeah.
these are everywhere. You just have to find them.
Awesome. Well, it's been a super interesting conversation. I feel like I could pick your brain on this topic indefinitely. But I'm going to switch over to some of the questions from the audience. So one that's come up here is, Matt, do you have any advice on what guardrails we should have in place to ensure that we maintain the right governance as you explore different models?
Yeah. I think the use case that you're looking at makes a big difference because there was a lot of fear around GenAI at the beginning of these models because like the first use case that people thought about was like we're going to replace our customer facing interfaces and customer facing chatbots with GenAI, and then some statistical model is going to make statements on behalf of the company, and that's obviously really bad. And what if they say something that's embarrassing? So then there's the other concern around like data compliance and let's say locality and so on. I think we've addressed these. So like I think it's the same guardrails that if you would use for any other kinds of data integration with the different providers. So maybe using a data loss prevention suite before sending data out to the external provider if you don't have like complete trust in their security. That's always a good practice. And if you can run like models in your infrastructure or within a cloud that you're already sharing data with, then like using LLMs doesn't bring additional risk in this case, as long as you don't expose them to customers. I'm talking about the internal cases where you use LLMs to understand data or to perform tasks. Um, Ultimately, like you want humans to be in control, and your employees are the people that will be responsible. So, matter of having proper policies in place. Like if you have ChatGPT write an email, you have to read it before you send it. Things like that. I think sometimes it's simpler than we think. Uh, yeah, that would be it.
Awesome. So maybe like what I heard there was a bit of a delineation between internal and external use cases as kind of just a
Mhm.
starting point. And then, going through your standard security procedures, policies, and protocols you would with anything that you might use internally is kind of the level of guardrails that you think is like you don't have to reinvent the wheel, I guess you're kind of saying on how to explore these things. Awesome. Um, Here's another question. It said you talked about starting with big models for experimentation. At what point or when would somebody know they can start to go down in size?
Yeah, so it depends on the volume that you have. I think it makes sense to go down in size once you start wanting to optimize the system for cost and latency. And you can do prompt testing at scale with the right tooling. You can say, hey, take these interactions that I've had with the model and then run them with this other model. And then you can either have some rules to go and evaluate the performance of the answer, or depending on the size, like just hand evaluate them qualitatively and then verify that it works. For things like summarization, small models tend to perform really well just because they're not creating anything new. So the degrees of freedom that they need to have isn't that great. But this is very task specific.
Okay. Um, there's another question that came up that kind of dovetails to this nicely is like, how does prompting maybe differ across some of the models, or does it?
That's a good question. Like sometimes model will make mistakes, and often your prompting will evolve in order to correct the issues that you see in the model. So if you're trying to summarize things at scale and get like a clean list of bullet point items that were talked in a conversation, you start with OpenAI and then you get some responses where it says, well, the first speaker said this and then the other speaker said that, and then you could amend your prompt and say, use a bullet point list of items. Here's a sample conversation. Here's how it should be outputted. So I think the general strategies are similar across models, but you need to have an iteration loop where you go and experiment with them because you'll hit different edge cases with different models that then you'll need to fix using different prompting strategies afterwards.
So this sounds like it's maybe like quite applicable when you're dealing with more robust projects, but maybe for the everyday user who's, doing some of these simple use cases you described, like summarizing something or, trying to just get a generated output or something like this that's really simple, it might not be as noticeable or relevant.
Correct.
Okay. The personal question just seems kind of a fun one. What are you kind of looking forward to in the next wave of releases from the different models?
What a fun question. I think. Oh, I think the big thing that lacks right now is the ability for models to know when they don't know things correctly and reliably. Um, that's basically the hallucination problem because ultimately they're trying to complete a sentence that is prompted, and you can ask it things that are not known at all. It will start imagining things. So having a good metric for knowing the certainty of what the answer is, I think is what I'm the most excited about in the GenAI space.
Very cool. Yeah, it sounds like that would be really valuable for a lot of people. I mean, even just thinking about the question around guardrails, if you had that, you probably have a lot more confidence in exploring models and testing things, right? Because I think at the spirit of it is this fear that, and a reasonable fear or concern that it's going to spit something out that's going to be detrimental to your business, and it's going to be hard to retract from that. That really interesting. Okay, last question here. Are there any trade-offs that might come with fine-tuning a model? And where do you see companies kind of normally start doing this?
I think fine tuning is an optimization strategy. So first of all, to fine tune, you need data, and this data is usually in like almost question answer pairs. So you will have like what the model was prompted with and what it generated, and or what you want it to generate, and then you'll go and either use some tooling to do it locally or use some providers APIs to fine tune it. And your objective is to improve the overall performance on this specific task. So the first requirement is lots of data, and it's possible that you can generate this data using past interactions. And if you're in a cost optimization mindset, that's definitely a viable option where you can say, let's use the bigger model and get the highest quality answers, and then let's use that to train a task specific model. And maybe in the process of doing that, we manually go and change the answers that were wrong, and we make them right answers or right completions, and then you fine tune. The trade-off is always around how generalizable the model will be. And that's a challenge in fine tuning anything. In machine learning, we call that like catastrophic forgetting. And it means what what it sounds like. It means that like you're going to give it data and it's going to forget all of the things that it has learned before and just start being very hyper specialized on that data. And there's safeguards to prevent that from happening. And I think because they don't really publish the strategy around that, but like platform providers will go and introduce some general purpose text or like some part of the original training data within your fine tuning data, just so that they can keep like some ground truth correctly. But yeah, that's the trade-off. You're getting hyper specialized to one task. You can go smaller, so it's good for performance, but you lose generalizability.
So there's a cost benefit effectively of fine tuning because you'll be able to have a smaller model that's more affordable to operate. Would that imply then that you would probably need a use case that is, relatively high volume or high impact to like justify that effort?
If your only purpose is cost saving, yes, you can get better performance. Like even the latest models will fail in some cases. So like if you have a data set of how this model should correctly behave, and maybe you bootstrapped it by using the latest model and fixing things, like it doesn't matter how you get this data, then you can get better performance for a more specific task.
Got it.
But that's always the trade-off. Like GPT, like the latest GPT-4os and like these big models try to be good at everything. And like we think there's smaller and like mixture of experts, like sub models behind the scene, but we don't really know. But when you fine tune, you say, I want to do this thing really well. And you start having models that can say, write SQL queries for your databases from text. And that's something where you can really fix things, and you can have lots of data, and you can have a model that's really good at writing database queries based on English language text. And that's a good example of why you would fine tune a model, because the general purpose one, let's say, won't perform as well as you want to. And it's possible to get tons of training data to go and make it better.
Makes sense. This has been a really amazing conversation. Appreciate you patiently answering all of my questions that I've peppered at you. I always learn so much when I get the opportunity to speak with you, Matt. For those of you in the audience, thanks for attending today and sticking with us. If you'd like to learn more or talk to us, feel free to book a consultation. Happy to spend some time with you. The link's down here in the chat. Yeah, and I hope everyone has a really great day.
Always a pleasure.
Thanks, Matt. See you.